I'd like to welcome up to the stage our first presenter for the evening, GrollTex. Sound check. All right.
Good evening, ladies and gentlemen. It's an honor to be here today. My name is Alexander Zaretsky, and I'm a nerd. I represent GrollTex today, a company that's currently taking shape around a method of inexpensive and waste-free fabrication of large area graphene that's going to be used for solar cells and flexible displays. So imagine a flexible touchscreen display that could be rolled up in a tube and placed in a pocket of a jacket, like this roll-up phone prototype by Samsung, or a solar panel that could be collapsed to the size of a grapefruit and later unfurled to cover an area the size of this entire room. Well, both of these technologies have one common element: a flexible, transparent, conductive electrode, a TCE. It's that transparent sheet that delivers power to our monitors and that takes the generated power away from our solar cells. TCEs are everywhere around us. They're in our computers, in our cell phones. And the current market for TCEs is at $1.6 billion per year. And it is expected to grow to more than $10 billion by 2016. Currently, the market is driven by LCD displays, but it's supposed to shift towards thin film photovoltaics due to their astonishing 60% annual growth in global installations. Currently, the market is completely dominated by indium tin oxide, which occupies 93% of this entire pie. This material is rare, brittle, expensive. It's mined predominantly in China, and these are the reasons why in the last few years the scientific and engineering community has been pushed so far to find an alternative. And for quite a few years now, graphene has been known to be the best TCE material. Graphene is a single sheet of carbon atoms with unprecedented electronic and mechanical properties. This material here is 200 times stronger than steel in tension and is a better conductor than our best metals, copper and silver. But the best part about graphene is that it completely consists of carbon. And carbon is non-toxic, carbon is everywhere in biotechnosphere, and carbon is cheap, sometimes even free. The only problem with graphene TCEs is that up to this moment there has been no method of manufacturing large area graphene economically and environmentally feasible fashion. For example, the current state-of-the-art method of fabricating large area graphene utilized by such companies as Sony and Samsung, for example, involves growing graphene on thin copper foils similar to aluminum foils found in our kitchens, and then submerging these copper foils into baths of acid that eats all the copper away, thus liberating graphene. As you can imagine, this process is dirty, very wasteful, and destructive. And indeed, it takes tons of copper foil to generate grams of graphene. And even more toxic and acidic waste are generated in the process. Conversely, GrollTex process generates large area graphene in a roll-to-roll manner and transfers it onto customers' choice of substrate inexpensively and with absolutely no waste. And here's how we do it. Instead of using thin copper foils to grow our graphene on that later are completely destroyed, we use chemical vapor deposition to synthesize graphene on precisely manufactured, precisely machined copper cylinders, or rolls as they call them in industry. And later we use electrostatic force, the most fundamental force in nature, to transfer our graphene from a growth substrate onto an arbitrary substrate, for example, a PET film as represented here. This process is continuous, so it results in sheets of graphene of almost unlimited length. It's very scalable and compatible with the current thin film manufacturing techniques. Since we're not losing a single gram of copper, our catalyst is indefinitely recyclable, and we also recycle synthesis gases in our reactor. The only thing that comes out of a tailpipe besides graphene is hydrogen. Hydrogen, the same fuel of the future. So in Mark II reactor, we'll use that hydrogen with a hydrogen fuel cell to power portions of our system. Our first customers are going to include manufacturers of displays and monitors such as Sony, Samsung, Apple, and LG. And later, when thin film photovoltaics really take off, such players as SunPower, NanoSolar, and First Solar will come into play. Currently, we have great interest and great feedback from such companies as Corning Glass and Polaris Battery Labs. Polaris Labs are actually our strategic partner in scaling up our manufacturing because they have great expertise in thin film manufacturing scale-up. So since currently there is no other method of manufacturing large area graphene in a feasible fashion, we're going to be the first in the market of graphene TCEs. I've mentioned our main competitor is ITO, the material that is rare, expensive, it's brittle, so it does not allow for flexible electronics. It has to be imported, and it's dirty. There are other transient technologies, such as carbon nanotube or silver nanowire meshes, but they are technologically inferior to graphene and at least an order of magnitude more expensive. So our main competitive advantage will be low cost. We'll be able to produce graphene at $1.73 per square meter. We can compare that to the cheapest ITO, Chinese ITO, that one can find at the moment on the market, that runs for about $20 per square meter. And a curious fact, if you would like to buy graphene right at this very moment, you would have to pay about $1,000 for a 10 square inch piece. So our process generates zero waste, and we can use local raw materials. Our main feedstock gas is methane, and we can use methane, for example, from a local South California landfill to feed our system. Again, the process is truly scalable and compatible with the current thin film manufacturing techniques with metallization, for example. So right now, GrollTex has proof of concept prototype complete. We have our patent pending, and we have all the licensing privileges from UCSD TTO. We own our GrollTex.com domain. We have won a prestigious Department of Energy South California Clean Energy Acceleration Program. And we've won the UCSD Entrepreneurship Challenge elevator pitch, which was a $500 award, but was very important for us because it helped us generate two very important venture capital leads that we're going to use in the second round of funding. And again, we do have Polaris Labs as our strategic scale-up partner. So currently, we're in the first round of funding. We need $75,000 in order to patent and license our technology from UCSD TTO, and also to build a scaled-down manufacturing prototype that we're going to use in the second round of funding. In the near future, we're hiring a CEO. Our current candidates have exceptional experience and are bringing not only capital but also connections to the established venture capital funds to the table. So for the second round of funding, we estimate the need of $3 million in order to be able to construct the first production line, showcase production line, by the end of 2014, which will be able to generate $3 million in revenue and produce enough graphene to cover up to 30,000 households worth of solar panels, half a square kilometer. By the year 2020, GrollTex Corporation will be the global leading supplier of graphene at large, and we are planning on occupy 5% of TCE market, which corresponds to $1 billion in revenues. And it's at that point where we'll start thinking about stepping into new markets. Graphene is anticipated in many different technologies, many different industries for myriads of different applications. We can start thinking about all graphene integrated circuits, all carbon integrated circuits, gas filtration membranes, and so on and so forth. Luckily, our patent is amendable. But whatever happens to us in that distant future, we're still going to be based in San Diego. So here are the projections for the 2 first years after the opening. By the year 2016, we plan to reach $1.6 million in net profit. Here are the faces of GrollTex. My name is Alexander Zaretsky. I'm the primary inventor and founder. I'm currently a UCSD nanoengineering PhD student, together with Timothy and Adam. Tim has a graduate degree in physics, and he's our physicist on call. He's our scale-up specialist. Adam has experience in finance and business, so he's going to be responsible for customer engagement and capitalization. Professor Darren Lipomi is our subject matter expert. He's also our technical advisor and business advisor. And we're also very lucky to have Dr. Rakesh Kumar from Pon Liebig Center for Entrepreneurship as our business advisor. And our two Rady MBAs, Justin and Yafe, are working on business model development and marketing strategies. So the important points here is that within the next 3 years, TCE market will increase 5-fold. Graphene makes the best TCEs, and GrollTex makes the best graphene. So we do it locally, inexpensively, and with absolutely no waste. And again, graphene is a highly expected commodity all over the world, so we're not going to be only limited by TCEs. At this moment, I'd like to thank my group of very stubborn nerds, Von Liebig Center for their support in business development, and Entrepreneurship Challenge staff, of course, and Department of Energy for their financial support. Thank you very much. I'll take your questions.
So now we'll hear 5 minutes of questions from our judges.
So over the next 12 months, what would you say are your 3 biggest challenges?
In the next 12 months, the biggest challenge is to build a scaled-down manufacturing prototype, to be able to create the patent landscape, the entire patent landscape, and to be able to create a utility patent and license it back. At that point, once we have the entire patent package, we'll move forward easily.
How much do you think you're going to need to manufacture before you can tell whether the process actually works fully?
We need $75,000 in order to be able to demonstrate the entire process at large, in full, I'm sorry, to investors. But then our first showcase production line, fully capable production line, will require about $2 million, mostly in custom build parts. So we need about $2 million to just build equipment.
Have you engaged with any potential clients about testing the product?
Yes, we have spoken to our main potential customer and our scale-up partner, Polaris Labs. They're actually in testing business, so they are going to provide us later with certification for all our materials. So yes.
So what would be your business model, and then who do you be your sort of initial customer?
So there are a few ways GrollTex can develop. Ideally, we will be producing graphene sheets ourselves and distribute it to display manufacturers. As I mentioned, Samsung is working on flexible displays. So that will be our first segment of market that we'll attack aggressively, initially at least. And then, of course, graphene is the best material for thin film photovoltaics, and those are really starting to pick up. So that's the second stage customers for us.
2 quick points. This is a process. Your IP is with process, is it not? Are there any options, any alternative processes that could produce an equivalent result? And let me add to that too. You have Sony Electronics here. Have you talked to them at all about any strategic alliance?
No, we have started 4 months ago, so we're very young.
You're early.
We are early. We want to keep that momentum, but we have spoken to Corning Glass and Polaris Labs. So far, we would like to first establish ourselves to make sure we do not make any wrong steps left and right talking to.
But are there any possible alternative processes that could yield similar results?
Yes, there is a process that is employed by Sony. In fact, they manufactured a 100-meter long sheet of graphene that was 23 centimeters wide, but in the process, they destroyed kilograms of copper and generated almost a ton of acidic waste. So technologically, this can be achieved. but it will not be neither economically nor ecologically feasible enterprise.
So when you were describing the ITO, you were saying that it was brittle and not particularly flexible. So what are the manufacturers? So when I've gone over to Asia, I'm actually seeing them creating these flexible displays. So what are they using to create these flexible displays if the materials you're saying aren't particularly flexible?
So ITO is a ceramic. It can be flexed. You could flex it and keep it at that position, and it would slowly degrade. So it's since it's a ceramic, it's brittle. They're using thin film of ITO, so they can repeat this flexure a limited number of times, and then after that, it degrades. It loses its property. So yes, you could roll it up and put it in a tube, but then if you repeat this process 3-4 times, the conductivity goes drastically down. Just because of the fact that bulk material is ceramic. It's in its nature not flexible. In thin films, it's more flexible, but still intrinsic brittleness exists.
That's all the time we have for questions. Let's hear it one more time for GrollTex.